Today we have two crucial things to discuss about. First, we are going to talk about the effect of the greenhouse, and for the second part, we are going to talk about the materials of solar energy. Part 1. What is the greenhouse effect? The greenhouse effect happens when certain gases, known as greenhouse gases, collect in Earth's atmosphere, and these gases which occur naturally in the atmosphere include carbon dioxide, methane, nitrogen oxide, and chlorofluorocarbon. Greenhouse gases let the sun's light shine onto Earth's surface, but they trap the heat that reflects back up into the atmosphere. In this way, they act like the insulating glass walls of a greenhouse.
Earth is a comfortable
The
place
greenhouse
to live
effect
and
keeps
It's just the right
climate
temperature for plants and
comfortable,
animals,
and
including
without it,
humans, to thrive.
surface
Why
temperatures
is Earth so
would be
special?
cooler and
Well,
many
one
life
reason
forms
is
would
the greenhouse
freeze.
effect.
For further
A greenhouse
understanding,
is a building with glass
let us
walls
watch
and
this
glass
movie
roofs.
together.
The clear glass allows sunlight to
everyone.
shine into the greenhouse while also trapping the sun's heat inside. This is how a greenhouse keeps plants warm even at night and in the winter. The greenhouse effect keeps Earth warm in pretty much the same way. Earth isn't surrounded by glass, but it is surrounded by a jacket of gases called the atmosphere. In the daytime, the sun shines through the atmosphere, warming Earth's surface. After the sun goes down, Earth's surface cools. This releases heat back into the air, but some of that heat is trapped by the gases in the atmosphere. These heat-trapping gases are called greenhouse gases. Carbon dioxide, water vapor, and methane are all examples of greenhouse gases. Earth needs a balance of greenhouse gases to maintain just the right temperature for living things. But some human activities are changing Earth's natural greenhouse effect. For example, burning fossil fuels like coal and oil releases more carbon dioxide into our atmosphere. These extra greenhouse gases can cause the atmosphere to trap more and more heat, leading to a warmer Earth. NASA satellites are constantly measuring the gases in our atmosphere from space. They've observed increases in the amounts of carbon dioxide and other greenhouse gases. The information from NASA satellites can help scientists figure out where greenhouse gases are coming from and how they are ending up in our atmosphere. This information will help us better understand the impact that greenhouse gases have on our climate, and help us better understand this very special greenhouse that we call home. What is the greenhouse effect?
Hi, I am Amirul Ashraf, and today we are going to explore the magic behind solar energy, specifically how crystalline silicon is used in solar cells to harness the power of the sun. So, solar panels are fascinating devices that convert sunlight into electricity. At the heart of most solar panels is a material called crystalline silicon. But what exactly is crystalline silicon, and why is it so crucial for solar cells? So, crystalline silicon is a form of silicon where the atoms are arranged in a highly ordered, repeating pattern. This crystalline structure is what gives silicon its remarkable electronic properties, making it an ideal material for solar cells. So, silicon is the second most abundant element in the Earth's crust, and it is extracted from sand. The silicon used in solar cell is typically purified and then formed into wafers. These wafers are then cut into thin slices, which are the building blocks of solar cells. So, there are two main types of crystalline silicon used in solar cell, which is monocrystalline and polycrystalline. monocrystalline silicon is made from a single continuous crystal structure, which allows for higher efficiency. Polycrystalline silicon, on the other hand, is made from multiple silicon crystals, making it less efficient but also less expensive to produce. So, how do silicon wafers generate electricity? When sunlight hits the silicon, it excites electrons, which creating an electric current. This process, known as the photovoltaic effect, is the cornerstone of solar power technology.
Moving into
Hi,
thin film
I'm
technologies, they use less active material and often involve sandwiching the material between two pans of glass. They are heavier than crystalline silicon panels but have a smaller ecological impact. There are 4 examples of thin film materials that I will talk about, which are cadmium telluride, copper indium gallium selenide, silicon thin film, and gallium arsenide thin film. Cadmium telluride is the only thin film material that reveals crystalline silicon in cost per watt. Despite cadmium's toxicity, the material is stable during normal operation and even in residential fires. Copper indium gallium selenide is another thin film material. It has high efficiency and can be fabricated using less expensive, non-vacuum processes. Next is amorphous silicon, are well developed and use a higher band gap to absorb the visible spectrum more effectively than crystalline silicon. These cells are often combined in layered cells to improve efficiency. And the last one is the gallium arsenide, which used for high-efficiency single-junction thin film solar cells. Although they are expensive, they hold the efficiency record and are often used in space application where efficiency is prioritized over cost,
allowing them to absorb different parts of the solar spectrum. These cells are made using metal organic vapor phase epitaxy and are used in terrestrial concentrated photovoltaic (CPV), which utilize lenses and mirrors to concentrate sunlight into the cells. High concentration photovoltaic HCPV can concentrate sunlight up to 1,000 times, potentially surpassing conventional solar PV in efficiency. Tandem solar cells combining gallium indium phosphide, gallium arsenide, and germanium junction are gaining popularity despite high material costs. The price of materials like gallium and germanium has significantly increased. These cells use high purity materials critical for substrate manufacturing. A typical triple junction cells might use GAAS, GE, and GALNP2. These cells have powered Dutch World Solar Challenge winners in multiple years. GAAS-based multi-junction cells are the most efficient to date, achieving a record efficiency of 44%. Silicon single-junction solar cells have nearly reached their efficiency limit of 26%. To improve efficiency, additional cells with higher band gap energies can be added to convert more sunlight into